Okay, this is for wrestlers and Hallie and Aubrey. Yeah, okay. So this sheet is not blue on my sheet, but it's blue on your sheet. You have a blue sheet, and this blue sheet is a sheet that you get to use on your test, which means you need to fill it out, and it's going to have all the equations and everything that you need. Okay, good? All right, fundamental counting principles is the top one. I'm going to go through this kind of fast, but stop me if you get stuck. I'm going to start with the examples. So let's say I have 4 poster boards, 6 ribbons, 4 pens, and 2 things of glitter. How many boards to create if 1 each section or 1 each category?
You can fit a lot more than what I can fit.
Yeah.
You can paraphrase more than that. I don't care. You have 4 poster boards, 6 ribbons, 4 different kinds of pens, and 2 things of glitter. How many different boards can I create if I have to choose 1 from each category? So maybe I choose the black board, and I choose the pink ribbon, and the gold pen, and the silver glitter. Right? Or maybe I choose the blue board, the blue poster board, and the yellow ribbon, and the pink pen, and the gold glitter. Right? How do I figure out how many different poster boards can be created with these options?
Isn't it just the lowest number?
Multiply them all together. 4, I'm going to do the solution. 4 different poster boards, 6 different choices for ribbon, 4 different choices for pen, and 2 different choices for glitter. If I multiply those all together, I don't know, this is 24 and this is 8. 24 times 8 is 160 plus 32 is 192. I don't know. Is that right?
Yeah.
Yeah?
No. Yeah.
No.
192.
192. Awesome. Okay, so what's the equation for that? What do we write as our equation? N1 times N2 times N3 times N4, and I keep going until I have all of my options, right? For important information, N is the number of options that you have. N equals number of choices in each category, right? So 4 choices, 6 choices, 4 choices, 2 choices, whatever, right? Okay, makes sense? Fundamental counting principle. You're just counting up the options by multiplying them together. Got it? Okay, permutation. I don't write down an equation for permutation. I just write down like NPR, NPR and NCR, okay? And N equals and R equals, and I'm doing that for both of these categories at the same time because N and R are the same for P and C. What does N stand for? What? What? The total number. The total number of options. Okay, what's R? The number you're choosing. Okay. All right. Example. Oh, by the way, maybe we should put in important information. How do I know it's a permutation? By the way,
All of them, right?
Order matters.
order matters. I'm going to say yes, order, and in combination, no order. Okay. For example, for combination, committee. If you have a committee, everybody is doing the same job. So does the order in which I read their names matter?
No.
No. What about for permutation? What do you remember for that? President. President starts with a P, so does permutation. So president. If you choose president, vice president, secretary, it doesn't matter the order that you choose them in. Yes, because you want to be chosen first as the president. Or maybe not. I don't know. Example. Example. 10 students. Run race. How many ways to choose first and second? Does order matter?
Yes.
Yeah, because you want to be first, right? 10 students. Run race. How many ways to choose the top two? Does order matter? If I'm just saying the top two. Top two in any order, right? Do we see the difference between those two? Order matters, order doesn't matter, right? Okay. So, what's n, by the way? N is total number, which is? 10 in this case. So here I'm doing 10 P, how much? 2, which is something. And 10 C2. Okay, I would, if I were you, get your calculator out and remember how to, where this button's at. Okay? Because I'm not going to tell you come test day, which is going to be like next week sometime, right? So make sure you know on your calculator where the P and the C button are. NPR and NCR. Make sure you know where it's at on your calculator.
I do.
10P2 is 90. Thank you. 90 different ways of choosing first and second out of 10 people.
45 is.
And 45, what?
Which one is it?
Go to the PRB button.
Like fraction of the decimal?
PRB button.
Probability.
Did you find it? Yep. Did you find what you're doing? Did you get 90 and 45? So you got to type in 10 first and then do P2.
I have to do
Simon, can you do a
math,
3C3?
probability,
Writing your name, man.
See if that equals 9.
player.
Too easy.
Okay, now, you don't have to write this down, but what if they say find the probability that Macy is first and Sienna is second?
I'm the first one.
What's the probability that Macy gets first and Sienna gets second?
1
1 out of 10.
1 out of 90, right?
90, yeah.
If there's 90 different ways that they could come in those places, the chances of Macy coming in first, Sienna coming in second is 1 out of 90. Now, that's assuming that everybody's equally, like, whatever, right? Like, equal playing field, whatever. Okay, so, anyway, there's that. Okay, got it?
What do you want me to do?
Okay. But you're not gonna be able to do that right now. Can you wait and do that in a bit? Or sit or do something?
I can
Okay.
just chill.
Okay, choosing N of N, real quick. This one is, like, let's say, example. Let's say I have how many people are in a batting order? 9. 9 players. How many ways to line them up to bat?
Oh my god.
How many ways can I take those 9 players and line them up to bat? All players are batting, right? So basically my N and my R are both 8, true? Okay, now if N and R are both 8, by the way, is this a permutation or is this a combination? Does the order matter? You might not think it matters realistically because everybody's going to bat, but it will be a different batting order if I switch them around, right? So order does matter. So yes, order. This would be like NPN, right? Or if you're selecting all of them, you could do N factorial, right? They're the same thing. So this, in this case, this would be 9P9 or 9 factorial. Either way you do it, it's going to be something. I don't know what it is.
30. No, this is definitely not right. It's
What?
too big.
It's big.
It's
362,880.
362,880. I bet you that's right.
Yes, it is.
Yep.
Yep. Why is it so big?
Because you have to take 9 times 8.
Yeah. Because even if you keep all 7 people the same and you just switch these last 2 people around, that's still a different combination, right? Like, that's a lot of switcheroos you could do with just 2 people at once, right? Like, that's a lot of combinations. Whoop.
9 times
'Kay.
8 times 7 times
Yep.
5.
Okay. What?
How many are we?
I don't know. As many as we can.
Oh.
All right, permutation with repetition. I'm going to start with the example here. How many words to spell with letters
SAT.
No.
RT.
No.
There's one word.
NA.
talking about?
If you do not know what that's from,
JACOBOWEN. Nobody. ZACHARY. Does anybody have two letters that repeat in their name? Two letters. Two letters.
Oh.
Two sentences.
S-C-
What?
Yeah.
Yes, Kellen.
Because Kellen can also spell Ellen.
the only thing he's good for.
All right.
So funny.
Okay, do we remember the problem with this happening when you have repeating letters or repeating numbers, right?
No.
Because if I'm trying to spell Kellen, and I pull the letters out of the hat, 1, 2, 3, 4, 5, 6, it's going to spell Kellen. Or if I pull them out, 1, 2,
5.
3, 4, 5, 6, that'll still spell Kellen. If I switch the two E's around, right, it still spell Kellen. Or if I flip the two L's around, right, like that's all the same combination. Okay? So, normally, this is normally what I would do, right? I would say Kellen has 6 letters. How many, don't write this down. How many letters could I pull out first? 6. How many letters could I pull out second? 5, 4, 3, 2, 1, which sounds like 6 factorial. But because I could switch his repeating letters around, I have to divide those out, which is 2. Why do I put 2 factorial?
Because there's 2 letters. There's
Like E repeats 2 times and L repeats 2 times. So I have to do 2 factorial divided by 2 factorial, right?
this is
Okay? Okay, by the way, what is 2 factorial? 2 times 1? 2 factorial is 2 times 1, so I could just take 6 factorial and divide by 4, right?
Yep.
And that is how much? 180? So there are 180 different words. Most of them will not be words at all, right? Like we'll have some really weird spellings of the letters of Kellen, but it doesn't matter, right? 180, okay? All right, what's the formula?
I don't know. N factorial over
I'm going to put it over here. N factorial over what?
N factorial.
I just say R1 factorial times R2 factorial, dot, 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 however many repeats that you have, right? N is the total number. R1 and R2 and R3 is the number of repeats that each one has, right? Okay? That's how it works. That's how it works. Okay, we did not do a circular permutation, so I'm going to cross him off of our sheet. We didn't talk about circular permutations. I can give you the formula for it.
Nope.
There's a question about it on your review that I'm also going to cross out, but it's fine.
Yay.
Circular permutation, we're not going to do this. I don't know why your book takes it out. 2 years ago it was in there. I mean, this is the same book company, so they evidently think it's not important now. Whatever. It's not that hard. Okay. Independent and dependent. Put a little loop on the side over here. And these two have to do with each other. These have to do with multiplying the probabilities together. And you multiply when it is an and when it is 2 or more events. That's how you know it is you are to multiply. 2 or more events. Okay? All right, the two things are independent. If I'm taking the fraction times the other fraction. Are you writing this down? You better be writing this down. Okay, fraction times the other fraction. If they are dependent, such as like you took the card and did not replace, what happens to this guy?
It's one lower.
You subtract 1, right?
Whoa.
Subtract 1 from the bottom number. Sometimes you subtract 1 from the top number as well. When did you do that?
When it's like, when
When
they
you draw a
king
king
are
and you have to draw it
red.
again.
When it's 2 of the same card, right? King and draw it again, right? Okay? So you subtract 1 from the bottom number. Sometimes you subtract 1 from the top number also. Got it? Okay, you're just multiplying fractions. Example. Should I do decks of cards? Find probability of a 7 and then an ace with replace.
Well, I want to take this, like, I can also fight.
So it'd be 1 up.
Okay, 7 and then an ace with replacing, 7 and then an ace without replacing. We'll do these at the same time. 7, ace.
Dog turd.
I want a 7 here. I want an ace here. Okay, 7 here, ace here. How do I know I'm multiplying?
And
And also
Two things.
2 cards, right? I'm drawing 2 cards. I'm not just drawing 1 card. I'm drawing 2 cards. Okay? What's the probability of drawing 7?
4 out of 52.
4 out of 52. What's the probability of drawing an ace?
4 out of 52.
4 out of 52 because there are 52 cards in fact in there. What is 4 of 52 reduced to? 1 over
13.
13 and 1 over 13 and 1 times 1 is 1 and 13 times 13 is 169. There you go. Okay? All right. Drawing a 7? 4 out of 52. Drawing an ace? 4 out of 51. 4 out of 52 does in fact reduce again to 1 over 13. And 1 times 4 is 4. 663. There we go. Beautiful. La, 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 la. There's not really any important information in there. I don't know what else to tell you. You could put here with replace,
Can we call that a day?
without replace. No. We're almost done.
So we can do my hair.
We're almost done. These guys have to do with adding. And you add when it's or. And you add when it's only one event. Now you might say, I want 1 card and I want to know if it's either a king or a 7, right? So 2 categories, but I'm only drawing 1 card, right? Yeah. What are you doing?
The little like
Yeah, the Venn diagram.
I don't have big enough.
Okay, they are exclusive. If you have 2 events that are not touching each other, such as like in decks of cards, give me an example when they are not
Perfect.
inclusive, when they are exclusive.
Clubs and hearts.
Clubs and hearts. Oh gosh,
Spades.
is that a club? That's
Spade.
a spade. Okay, we'll go spades and hearts, right? Spades and hearts. Okay. If that's the case, and I have spades and hearts, I want chances of spades, and I'm going to add 2 chances of hearts, and I'm going to get a final answer, right? Okay, so let's just do that. Find probability of a spade or a heart. That's it. Find the probability of a spade or a heart. Solve it. How many spades?
13.
13 spades out of 52. Hearts? 13 out of 52, which is
So 1.
26 out of 52, which is half. Are half the cards spades and hearts?
Yes.
Yeah, that would make sense, right? Half the other half is diamonds or clubs, right?
Now can we put
No, child, we have like we're almost done. Inclusive though is when you have this going on. Give me an example of inclusive with cards.
Sevens and hearts.
7s and hearts. Okay? All right. 7s and hearts. So find probability of a 7 or a heart. Okay? Formula for this. I have to add the 7s to the hearts, but then subtract 1 fraction. Right? And that gives me the answer. Whatever. Probability of 7 or a heart. Okay, what's my chances of drawing a 7? 4 out of 52. Oh, by the way, maybe I should do this. 7s, there are 4 of them. Hearts, there are 13 of them. How many are 7s and hearts at the same time? 1. So, 4 out of 52 plus 13 out of 52
16 over 52. Man.
minus 1 over 52, because the one card is counted in both categories, and that is, he is right, 16 over 52, and if you divide by 4, you get 4 out of 13. Beautiful, beautiful, beautiful.
Mom.
Okay, really quick, last one.
Grandma.
I'll make these go fast.
What?
I don't remember mine. Oh, I do. Put the box at the bottom. We have boys and we have girls and we have. Should we just do? Who shall we do?
Only boys. Alright, now
Oh
we
no,
got
a
You
box.
should do false positive.
Freshman, sophomore, junior, senior. According to this list, there are 15 and 13. Sophomores, there are 14 and 15. Juniors, there are 8 and 7. Somebody told me this senior list is not right.
Something.
9 and 11, but they said that there's only 9 girls now in the senior class because Mary left and Olivia's gone.
Yep.
Whatever. Okay, boys total.
Chloe, can you zoom back out a little bit?
Oh, yeah.
We are the biggest class.
This is 28. Figure out my boys and girls for me, somebody. 29, 15, and 20 are my totals there. How many boys do I have? 20.
26.
20 plus 26 is 46 for both.
Oh, guess so.
So what are they?
I did the top one.
You got 46? Perfect. Okay. So that adds up to be 92, right? Okay. All right, let's do an example over here, and then we'll write the formulas down. So conditional probability is, I'll do 2 of them. Conditional probability. Probability of a boy given a sophomore.
Yay.
Probability of a junior dash girl. What's the dash mean? Given.
Means it's in the denominator.
Okay, this is conditional probability. Under these conditions, I'm not looking at all 92 students. I'm only looking at, for the first one, the sophomores. I only care about the sophomores. The sophomores is my new bottom number. Okay, so how many sophomores?
29.
14 out of
29. Of those 29, how many are boys? 14 out of 29. There you go. Okay. For the second one, I'm not looking at all 92 people. I'm only looking at the girls, right? Girls are 46. Of those, how many are juniors? Now, I have a lot of people that will do 46. They'll say 46 girls and juniors is 15. So 15 out of 46. Why is that not right?
Because there's the boys that.
Because we're not talking about boys that are juniors. We're only talking about the girls that are juniors. So is it 7 out of 46? Should be right. There you go. 7 out of 46. Okay. So probability of, I'm going to say A dash B whoop, determines bottom number. Oh yeah, 7 out of 46. P slash B or A slash B, probability of A slash B means that the B determines the bottom number. So you kind of like, I like start these and do these problems backwards. B is going to be your condition, under this condition, right? All right, complement. Find the probability of not a senior. Find the probability of choosing a student that is not a senior. How do you do that?
And the probability of senior and subtract.
Yeah, probability of senior is 20 out of 92. Senior equals 20 over 92. So that means not senior equals
72.
72 over 92. Whatever that is. I don't care. Just leave it. Okay, so what's a complement?
P bar.
The opposite.
Subtract. Yeah, it's P bar actually. Subtract. Okay. Complement is finding the opposite. Yeah. Yeah. Yep.
What
Yep.
class is this?
This is geometry.
No,
Okay.
that's stats, actually.
Maybe done now.
This is probability.
We can be done now. Okay.
Can I use the bathroom?
Yes.
This is actually.
Okay, tomorrow, find something to do. We have 10 minutes left. Find something to do. I do have your reviews run off. So if you do not find something to do to keep you busy in the next 10 minutes, I will give this to you and give you an assignment. Okay? Go find something to do.
All of it? No.